Hi, this is our Camp 2 Colligative Properties assignment. My name is Allison Darty.
I'm Kaylin Bray.
I'm Nicola.
And I'm Raina Darnay.
So first I'm going to walk you through what the goal of our experiment was. So the goal of the Colligative Properties experiment was to be able to identify an unknown compound. We were able to identify this unknown compound by completing our experiment of trying to find the freezing point depression. And then from the data we collected in our experiment, we were able to determine the molar mass based off some calculations.
Now, for the background, colligative properties are characteristics of solutions that depend on the number of particles within the solute and an amount of solvent, and these include boiling point elevation, freezing point depression, osmotic pressure, and vapor pressure lowering. For this lab, we used freezing point depression, which is the lowering of the freezing point of the solvent when a non-volatile solute is added. The solute particles interfere with the formation of the solvent's solid structure. The freezing point depression increases with the concentration of solute particles.
And for our experimental design, our experiment showed the relationship between freezing point depression and molality, which is shown through the equation on our slideshow. And it's delta T, or freezing point depression, equals the freezing point depression constant for the solute times the molality of the solute. And molality equals mole solute over kilograms of the solvent, and mole solute equals mass of the solute over molar mass of the solute. And using the freezing point depression we calculated in our experiment, the moles of the solute and subsequently the molar mass of the solute can be calculated with the equations above. For this experiment, we measured the freezing points of distilled water and an unknown aqueous solution using a Vernier temp probe and in an ice salt bath. And we had 3 trials for the unknown solution. Temperature data was recorded and compared to the distilled water freezing point depression to determine freezing point depression for the unknown solution and to calculate the unknown solute molar mass.
Now here's some of our data from the experiment. Here I have a graph for the temperature versus time for the pure solvent, which was our water, and then the temperature versus time for our unknown solute with the water. And the difference between these two graphs, for our water, we see that it kind of has a steady increase back to like regular temperature. It's increasing at first, and then in the middle it's kind of decreasing, and then towards the end it's reaching that point again. And then for our unknown solute, we see that it's a steady decline, and it's just constantly getting colder. And because of this, we can assume that it has a higher freezing point, a lower freezing point, sorry. And these are just the tables for the 3 trials. And some of the trends that we can notice is that across the 3 tables, we can see that the molar mass kind of relatively increases, as well as the mass of the solute. And then as for the temperatures also seem to decrease as we move along the 3 trials.
And then for conclusions, so using our lab results, we see that the weights are 119, 166, and 158 grams per mole. Therefore, the solute is more than likely glucose.
Thank you.
Thank you.
Thank you.
Thank you.